option that allows changes. So I asked you to try put operation. Have you seen which option is used for doing that? Actually, you have a attribute called, you have a property called enable reinitialize. It's a Boolean property. If you put this enable reinitialize, then it will allow to modify the values. So input operation, you have to set up that option. Then edit is possible. So in the to do application, so here in the edit, when you use edit, in the edit action, what you have to do on edit click, you have to enable one option. What is it? Enable reinitialize as true. If you set up enable reinitialize true, then it will allow to make the changes. So this is important. Then you can make the changes in these initial values. So that is one option you need to set up. Then on put, what you have to do, collect the data and send it to this task. This you finish, when you enable this, automatically it will allow you to make the changes. You try that. So so in this application, so when user sign in with Sam, right? What is the user? We have Sam React. At the net 11. Now when you click on this edit, it has to get the edit option. Here it should allow to make the changes. So that is what you have to do additionally, right? So rest of the post operation on submit, put the data and manage, all that you can try. Okay. So this is the example you need to design completely. Now once you are good with this, now you have a complete idea on MERN stack environment. That means we maintain database in MongoDB and API using Node and Express, and the front end we are using React.js. Now, all these days we worked with React JavaScript. So in several companies they ask React with TypeScript. So now you have to learn about the language TypeScript. So you need to know the language TypeScript. So if you know TypeScript, we can build the complete React application like to do and all using TypeScript. TypeScript have a few changes when compared to JavaScript. Those language changes you have to learn. Once you know these language changes, then you can implement in the same way. All examples what you tried in JavaScript and React, same you can try in TypeScript. But what is TypeScript? What are the features? How it works? How it is different? Few basic things we will see. Actually, first point is TypeScript is a strictly typed mode of JavaScript. Strictly typed mode of JavaScript. TypeScript is strictly typed mode of JavaScript. So it is a strictly typed mode of JavaScript. So you know already what are the issues of JavaScript. You learned already in JavaScript. JavaScript is not strongly typed language and it is not implicitly strictly typed. You have to turn on the strict mode explicitly. You know how to turn on the strict mode. You have to use strict. So TypeScript is implicitly strictly typed. What is strictly typed means? Strictly typed means it will not allow to violate any programming standards. Strongly typed means it is about data type. But strictly typed is about the rules and the standards of programming. Generally in JavaScript, if you don't follow the rules and write the code, it will validate, it will verify, it will run. You have to explicitly turn on the strict mode. But TypeScript is internally strictly typed. It is internally strictly typed. So generally it is called strictly typed mode of JavaScript. Actually, TypeScript, it is strongly typed language. JavaScript is not strongly typed language, and TypeScript is a strongly typed language. Just like other languages, C, C++, C Sharp, Java, it is strongly typed. That means when you declare a variable, you can set restriction for that variable, that it should store only number or it should store only boolean. which is not possible in JavaScript. JavaScript is not strongly typed. Actually, to make JavaScript strongly typed, external third-party libraries are used. Earlier in our old React projects, we used to use a third-party library. Through that, we can use JavaScript strongly typed. JavaScript strongly typed, we have separate library. We have to import that and use it. But now we are not recommending that. We recommend to use TypeScript. TypeScript is a strongly typed language. Strongly typed means it will restrict the data types. It can prevent accidental or intentional use of any other data type into a specific. JavaScript is not strongly typed, but it is strictly typed. And actually, so TypeScript, it is an OOP language. It is an OOP language. It supports all the features of OOPs, whatever object-oriented features are there. JavaScript is not a OOP language. JavaScript supports only few features of OOPs. It is not a complete OOP language. But TypeScript is a complete OOP language. Actually, so Anders Hazelberg. Anders Hazelberg, he developed, he introduced, Anders Hazelberg is the architect of TypeScript. He is the architect of TypeScript. He developed TypeScript architecture. So he is actually Anders Hazelberg, so well known for C# language. He is known for C# language. He is the designer of C# language, which is a language of Microsoft. So TypeScript belongs to Microsoft. TypeScript is a language which belongs to Microsoft. It is designed and maintained by Microsoft. Anders Hazelberg is the architect of this language, TypeScript. He is an architect of Microsoft. He is the main architect of a language called C#, which is a very popular language of .NET technology. So Anders Hazelberg is responsible for this TypeScript. Actually, TypeScript specialty is TypeScript is built with TypeScript. TypeScript is built with TypeScript. It is completely built with TypeScript. That means it supports low-level features. Low-level features. It supports low-level features. Actually, a language is usually built with another language. Usually, a language cannot directly interact with hardware. One of the drawback of OOP languages, they cannot directly interact with hardware. They use more memory. They cannot interact with hardware services. But specialty of TypeScript is entire TypeScript is built with TypeScript only. Means it is the language native to operating system. Microsoft operating systems, can understand this language as a native language. That means it doesn't require any another language to talk with operating system. TypeScript can directly interact with operating system. Actually, TypeScript, it is used to build large scale applications with Microsoft technologies. It is used to build large scale applications, large scale applications with Microsoft technology. So don't think that TypeScript is used for Angular or it is used for React like that. Individually, TypeScript is a huge language. It is built, it is used to build very large scale applications. Independently, TypeScript itself is a huge language. You are using TypeScript to just overcome the issues of JavaScript in web. But independently, TypeScript is more than that. That means what TypeScript you learn here is not the complete TypeScript. It is only the TypeScript required for technologies like Angular, Vue, React, like that. They use a portion of TypeScript to overcome the issues of JavaScript. Independently, TypeScript is very huge language. It is independently used for building large scale applications. That is the abilities of TypeScript actually. So don't think that TypeScript is a language used for Angular or React. They are borrowing TypeScript and using them. Actually, TypeScript is there before the world knows about TypeScript. TypeScript is there so earlier. So in early 2003 itself, internally Microsoft have a language called TypeScript. They internally have that. What happened is the Google people introduced AngularJS. AngularJS. Before Angular, it was AngularJS. They introduced this AngularJS. And AngularJS was using complete JavaScript. To overcome the problems of AngularJS, what Google have done, Google recreated a technology called Angular, which is complete reconstruction. Earlier, they used to have AngularJS. After that, they started Angular. But in Angular, they want to use a new language, not JavaScript, because of the problems with JavaScript. Google started a language called EtScript. They started a language called EtScript. So they started designing a language called EtScript to overcome the problems of JavaScript. They actually released a few versions of this EtScript. But what happened is Microsoft saw that Google is trying some new language which is already there by name TypeScript. Microsoft saw that Google people are trying one language and they were surprised because that language was same TypeScript. That means how TypeScript was, in the same way they were developing EtScript. Then Google and Microsoft together had lot of uh, internal contracts, agreements of using TypeScript as a language for Angular. Actually, TypeScript, Microsoft is not an open source in early days. it is not an open source. In the early days, it is not open source. That means Microsoft is having TypeScript, but they don't give this TypeScript to the public as open source. So Google actually Google EtScript was same like TypeScript. Then Google borrowed this TypeScript architecture. They asked Microsoft to make it as an open source so that they can start using this. Then in 2014, Microsoft made it as open source. And Google people started using this TypeScript in their technology called what? Angular. They stopped this EtScript because they released it in the beginning of Angular. When Angular started in 2014 and all, we trained people with EtScript. Angular with EtScript. Angular with JavaScript, Angular with EtScript. We trained people on that. But suddenly in 1-2 months it changed. By the time we trained a batch on EtScript, suddenly Google said that no more EtScript. We are using TypeScript. What happened in the background? We saw that Microsoft has made TypeScript as open source. Now TypeScript is available to everybody to use in their technology. TypeScript, why they developed? Because Microsoft have a language called C#, which is used for building web applications. It is used as a language for web applications, and with JavaScript it was facing a lot of issues. That is the reason they developed a language called TypeScript for their internal purpose. But this is now becoming so popular. Very recently, just 1 month back, Microsoft have successfully executed TypeScript in browser. Directly in browser, TypeScript executed. They have a successful trial run. Officially they announced. That means now in future it will be a very big revolution, because now currently browsers don't understand TypeScript. Browser can understand only JavaScript. Developers will write in TypeScript, which is translated into JavaScript. But they have a successful trial run of TypeScript directly in browser. But it will take a lot of time. It will take at least 2-3 more years that they can come to a conclusion that okay, TypeScript is safe for browsers. Then it will be a revolution that all worldwide web technologies now will be on TypeScript. Applications will be on TypeScript. Now majority people, alternatively for JavaScript, they use TypeScript as a language. But the problem is TypeScript is not understandable to browser. It need to be again translated into JavaScript. So TypeScript is used for developers to leverage all the benefits of programming language and implement for web applications. So don't think TypeScript as a language used for Angular or React. It is a very huge language individually, built by Microsoft for their internal purpose. So we are using its benefits for building web applications through React or Angular and all this. So this individually TypeScript can build very large scale applications. So how the TypeScript works, I will tell you. Actually, TypeScript is transcompiled into JavaScript in browser. So TypeScript is not directly understandable to browser. So developers write in TypeScript, it is translated into JavaScript and given to browser. So why developers use TypeScript? So that they can use all the programming benefits of TypeScript and build application in a easier way. Easy and fast with a lot of technical features. That is the advantage of using TypeScript. So let's see how this works actually. How TypeScript works. Actually, the TypeScript architecture. You need to understand how TypeScript works. What is the basic TypeScript architecture? Actually, this is the TypeScript architecture. So, this is the TypeScript architecture. So, this is Anders Hazelberg, the inventor of C Sharp language and TypeScript language. He is the architect of that. And this is the basic architecture of TypeScript. How TypeScript actually works. What is the basic architecture of TypeScript? Actually, you see here, TypeScript generally, TypeScript at the bottom, you can see it have a core compiler. TypeScript have a core compiler. So, TypeScript first important, it have a core compiler. It have a core compiler. Actually, what is the job of this core compiler is the TypeScript core compiler. It is responsible for translating TypeScript program. It is responsible for translating TypeScript program into OS native code, into the OS native code, operating system native code. It is responsible for translating the TypeScript program into OS native code. Actually, so it tracks the errors and the reports to developer. So it tracks the errors and reports to developer. Generally, it is responsible for translating. While translating, any issues are there, it will track them and it will report to the developer. Generally, core compiler is responsible for doing lot of activities internally. Every compiler in the world, Java, .NET, all these compilers internally have a lot of components. That means every compiler internally have a lot of components. Generally, people at learning level may not know about that, but experience level, developers know in the compiler what are the components and how they work. So we have compilers and how they work. This core compiler internally have so many components, like it have the component core TS, program TS, scanner, parser, checker, emitter. TS means I told you TypeScript is built in TypeScript. There is no other language in between. TypeScript is directly understandable to operating system. Computer hardware devices can directly understand this TypeScript. So actually we have core TS, program TS, scanner TS and all. These are the components inside compiler. Inside compiler, what these will do is actually you have core.ts, we have program.ts, we have parser.ts, scanner.ts, emitter.ts. So these are the checker.ts. These are the components of the compiler. So actually these type of components are present in every compiler. Every compiler have them. What is core compiler, program, parser? You know the word scanner. It is used for any idea? In computer programming, scanner is used for handling input activities. It is responsible for managing all the input activities. It is managed by scanners. You know, C programming and all, they have scanf. Why it is called scanf? Printf, scanf. Scanners are compiler components which are responsible for managing input activities. Every compiler in the world. Many people don't know what the compiler have inside, but inside compiler there are so many components. Java, .NET compilers, C Sharp, and Java, and Python. Compilers internally have so many. Scanner is responsible for input, emitter is responsible for output. All the output activities are managed by emitter. Input are done by scanner. Conversion of one type into another type is managed by parser. Verifying whether the data type and the value type are matching or not is done by checker. Checker is responsible for verifying the data types. And parser is responsible for translating the types, converting string to number, number to string. So core TS is responsible for providing, it is responsible for providing the basic platform for compile the program. To compile the program, a platform is created by core TS. And program TS is responsible for structuring the program. Structuring the program means where it should start with, where it should end. You know, every program have a entry point, main method. Where program should start, where it should end, where a block starts, where it should end. This is all decided by program. That means the structure of flow of execution is managed by program. So core TS, so it is the base for compiling. Program TS it configures the execution flow. Parser, it translates, it converts one type into another. Scanner, it manages input actions, and emitter, it manages output actions. Checker, it handles data types. Actually, it is called data structure. It handles the data structure. That is the basic component in TypeScript. TypeScript core compiler. So TypeScript internally have a core compiler. This core compiler have several components inside, and its job is to translate the TypeScript program and make it understandable to the operating system, so that operating system can understand your TypeScript. So here TypeScript have another compiler. TypeScript have two compilers, one core compiler and another one standalone compiler. TypeScript have another standalone compiler. We have a standalone compiler. So standalone TS compile. So we have a standalone TS compiler actually. Now what is this standalone TS compiler? So why you have two compilers? TypeScript have two compilers. What is the core compiler doing? It is making the TypeScript language understandable to the operating system. Means it is identifying the issues in program. It is checking the program. It is verifying whether the program is perfectly defined. There are no errors in the program. The keywords, the flow, the structure, everything is fine. Okay, after successfully translating, this program is not understandable to browser. Browser don't understand TypeScript. Browser understands JavaScript. So this TypeScript, after compilation finish, it is again compiled by a standalone compiler which translates it into JavaScript. So what is standalone compiler doing? What is the responsibility? It is responsible for translating TypeScript program into JavaScript. That is what it does. And who does that? Actually, tsc.ts. That is a TypeScript transcompiler. This is standalone compiler. So actually two compilation process will happen. First one, it will check are there any errors. If there are no errors, then another compiler will come. It will translate that into JavaScript. This is not required every time. This is required only when TypeScript is used for web. I told you TypeScript is not used only for web. Individually it is used. for building large scale application. When individual it is used for building large scale application, we don't use standalone compiler. We don't need to translate TypeScript into JavaScript because TypeScript is already translated into operating system, understandable code. In that case, this is used only for TypeScript if it is used for web. This is not required for TypeScript every time. If Angular, React, Vue, these people are using TypeScript, they need extra compiler. What is it? Standalone. Individually, TypeScript doesn't require because already it have a core compiler. So standalone compiler. So here the point is TSC is the standalone compiler. So it is used only for web applications. It is used only for web applications, the standalone compiler. It transcompiles TypeScript into JavaScript. So we have a core compiler and a transcompiler. Okay. Next, in TypeScript, here, another component in the TypeScript architecture, you have a language service. You have a language service. What is a service? Already we learned now. Service means it provides a predefined business logic. Already we discussed that consumer, provider, injector, right? So a language service is nothing but it provides the complete business logic required for a language. That means I told you that compiler will compile. It will verify whether the keywords you written are correct or not. You written the syntax correctly or not. For loop, if conditions, you written the structure correctly or not. From where it will verify. So that means the compiler verifies that you written some for each. Compiler verifies that you written for each. It immediately says we don't have a for each. Directly there is no for each in the TypeScript. It is the array method. Directly for each is not there. Now, how compiler verifies that for each is not there in its library? That means it is done by language service. Language service provides, service means I told you is a collection of factories, and factory is a collection of values and functions. So every compiler is going to compile by verifying the content from a language service. Language service contains information what is needed for a compiler. Compiler needs some information about the language in order to translate. That is provided by language service. So this is service.ts actually, language service. So it is a predefined business logic provided by TypeScript. It is a predefined business logic provided by TypeScript. It is the repository of TypeScript language, repository of TypeScript language, which is used by the core compiler, which is used by the core compiler. And its component is what? Service.ts. Service.ts. It is managed by service.ts. बच्चा को कैसे जन्म दिया जाता है, उसको चलाया जाता है, तेल लगाया जाता है, खिलाया जाता है, बच्चा को। So we have two compilers and you have one language service. Actually, you have another one, server. We have a TS server. We have a TS server. So TS server. TS server. Actually, TS server is, what is the job of server? The job of server in any technology. What is the job of a server? The server responsibility is hosting. Host. Server is responsible to host and manage the request and response. That means TypeScript programs are hosted and processed on server. So it have an internal server managed by server.ts. Managed by server.ts. This server.ts is nothing but, you remember, just we created app.js. In that we created our own server. It was running on 700 port, 7000 port number. So TypeScript internally creates a server. It will process the TypeScript programs. It will compile the TypeScript programs. And it is managed by this server.ts. It creates the server. It runs the server. It will host the TypeScript programs, compile them. It will manage the request and response. That means input, output, activities, everything is managed through this server.ts. So you have a server. Another one, in the TypeScript architecture, you have VS Shim. These are very high level concepts. Shimmers are very high level concept. If a person says that I know a technology, so which is cross platform, that means actually Java, .NET, all these technologies claim that they are cross platform. Cross platform means their applications can run on every operating system. That is because of Shimmer only. So what they don't know, maybe because at beginners level nobody knows that much in depth, who is responsible for that. Shimmers are present in Java, .NET, everywhere. We have a Shimmer library for Java and .NET. Java shimmers are there, .NET shimmers are there. Actually, the shim, it's a very interesting word actually, shim. Shim is a word taken from shrimps. Shrimps. It is taken from shrimp. You know prawns, right? Prawns and shrimps. Prawns and shrimps Do you know difference? No, no. So prawns and shrimp, if you know prawn and shrimp, you know prawns and shrimp images. You see the prawn and shrimp. Prawn and shrimp, they look same. These both are same. Both look similar. So, but actually, one interesting point is there. This is just a ordinary comparison. It is found in fresh water, this water, that water, right? But the actual technical difference is there. Biological difference is there. The difference is shrimp is gender neutral. It is gender neutral. So not female, not male. So neutral, gender neutral shrimp. Actually, here the intention of shrimp is to tell that it is platform neutral. That means it's not related to any platform. It's platform neutral. Shim libraries are present actually. Uh, Not required for you at your level, but Java, Shim library is there. Java Shim library is present. What is a Shim in Java? You have .NET C Sharp Shim libraries will be there. So shims for C Sharp also will be there. So this is a shim library for .NET like technologies actually. Any technology that claims that they are platform neutral, that is because of a component called shimmer. These are responsible for taking the code, translating it into in such a way that can run on every operating system services. That is shimmers actually. So what is shim and what is why VS means Visual Studio. Visual Studio Code shimmers. It is not Visual Studio Code, it is Visual Studio library actually, because it's a Microsoft library na shims. So actually Visual Studio Shim is a library from Microsoft. So Microsoft is a library from Microsoft. So used to make to make the language to make the TypeScript language platform neutral. Platform neutral. So it can run on every operating system. So you have shims.ts. These kind of details you will not find regularly in even on Google also. You have to go to their official libraries and find out about them, because they don't give these as general public repository. Information about these are not given as public repository, because technology have a lot of things they can't show you, they can't explain you. Why? Because they are important for their internal use, they are not required for outside, and you don't need them. That's the reason on Google also little bit overview only you will find, but in their official repositories you will find more about their details. Actually you have shimmers responsible for doing that. What they do is, when they convert the TypeScript into platform neutral, then another component will come, that is managed language service. a managed language service will come. You have two language services. One language service which will provide all the features required for TypeScript language, and another language service, it will provide all the features required for TypeScript to so that it is understandable to all platforms. That means what is this two language services are there. So you have a managed language service and a language service. What is difference between these is actually this is called unmanaged code. This is called unmanaged code. This is unmanaged service actually. This is managed service. Unmanaged service means what? It runs on specific operating system native to that operating system. So this is not platform neutral. You run on you run on Windows, it will work only for Windows. You run on Linux, it will run only on Linux. But managed service can run on every operating system. So TypeScript have both facilities. It can build platform specific, it can build platform neutral. Both options are provided. Platform specific apps, platform neutral apps. Actually, they are platform specific earlier because Microsoft apps can run on only Microsoft operating system. After few years, they made operating system. They made open source. Earlier, Microsoft is not open source. Microsoft apps are not open source. They cannot run on other operating systems. Later, they made it because they saw Linux and Mac are very much going to trend everywhere. Then they have a market plan for that. That's the reason they made open source after several years. Earlier, when we developed apps for Microsoft, they were not suitable for other operating system. Microsoft apps can run on Microsoft operating system only. But now they are platform independent. They made platform neutral. They have introduced this managed service. That means actually managed language service. So it is the language service used to make TypeScript understandable to every operating system, every OS, understandable to every operating system. So actually unmanaged code. So the unmanaged code is OS specific, and managed code managed code is cross platform. Unmanaged code is OS specific. So that is managed and unmanaged. You have a managed language service. Now, once you know this, that means this is all the architecture. Editors is nothing. Editors is nothing but to tell that it is understandable to all kind of IDEs, integrated development environment. Any editor can run and use and configure TypeScript. because some languages cannot be configured by some editors. But here it supports all editors. All editors are supported. So TypeScript is completely built with TypeScript. And internally TypeScript have a lot of components to manage the language. So we have a core compiler, transcompiler, language service, server, shimmer, and managed language service. What are those? Understood? Core compiler is responsible for translating the TypeScript program, finding the errors and fixing the errors, right? After TypeScript is translated, if you want to use TypeScript for browsers, web, then you need another compiler. What is it? Is standalone, which translate TypeScript into JavaScript. And whatever TypeScript requires as a language, the repository is provided by language service. And hosting and executing of TypeScript applications happens on TypeScript server. The TypeScript code is made cross-platform code by using shimmers. And the library for running the TypeScript on every operating system is managed language service. That is what the concept of TypeScript. Actually, internally, so much more is there. That's not required. This itself is too much. People who know TypeScript, they don't know all this. People who learn TypeScript for Angular like languages, they don't know this art. They don't know this, but they say that I know TypeScript. That means they know TypeScript, but they don't know all this. This is only for extreme experience level. If you are showing vast experience, then they may ask the architecture of TypeScript. This is enough. More depth is there. That means actually for very experienced people, we explain how this works. Internally core TS, program TS. That's not required for you, right? This is enough. So because actually these architectures and all are very important for certifications. People do certification, Microsoft certifications and all. When they do certifications, in certifications, these kind of questions will come. These kind of questions will come. People who are trying to write certification programs and all, architecturally very complex concepts will come. These are all related to certification related. But having knowledge about that is good. Now, how to use this TypeScript in our projects? To use TypeScript in our projects, first you have to set up TypeScript on your PC. You have to set up TypeScript on your PC. TypeScript directly don't work. You have to install TypeScript to use in your projects. You install TypeScript on your PC, you can use in any project. It is not like TypeScript for specific project. You install TypeScript on a PC, then it can be used on any project. Angular, React, general web applications everywhere. So what you have to do, open Windows command prompt. You have to open Windows command prompt and run the command. You have to run the command npm install globally TypeScript. So that is the TypeScript you have to install globally. So you need to install globally. After installing, you can check the version. So TSC-V. TSC is, what is TSC? Just now you saw TypeScript compiler. We say core compiler, trans compiler. This is the compiler. TypeScript standalone compiler. Standalone compiler only, na? Standalone compiler only tsc.ts. That is the standalone compiler. This core compiler is not necessary here. It will internally used by trans compiler. So first open your command prompt anywhere in your PC prompt. You type npm install globally what TypeScript. So this is globally installing TypeScript. Okay, once it is installed, you have to check the version tsc-v. That is TypeScript 5.3.3 is the version. Companies still use TypeScript 3. Companies are still using TypeScript 3 version. At a maximum level, they are using 4. 5 is the latest version of TypeScript actually. So companies still use TypeScript 3 and 4. 4 is very recent actually. But now from 4 to 5 is very, very recent. But having knowledge of latest is okay. But companies still work on 3 only. TypeScript 3 and 4 are the very popular versions for companies. Actually, 5 is very latest version. So here once you run this, so the latest version will be 5.3.3. That is the version we have. Now, once TypeScript is installed successfully, now how to use TypeScript in our project? First, we will learn TypeScript as a language, separately as a language. Then we will use TypeScript with our React. So we will first learn TypeScript as a language first, means all the language basics and all, how it is different from JavaScript. Then we can use it, right? Now, what we have to do, we have to learn how to create a project and how to use the TypeScript. Here, one basic point is TypeScript programs have a extension .ts. So, and they are trans-compiled into JavaScript. How they are trans-compiled into JavaScript is actually, suppose index.ts, you have console.log, some welcome to TypeScript, some concept it is written. Later detailing we will learn. Now how to translate this into JavaScript. To translate this into JavaScript, you have to run tsc index.ts. You have to just run that tsc index.ts. Now what will happen is, so it will add a new file called, it will add a new file. Actually, what it will happen, generates index.js. It will generate index.js. Index.js is the JavaScript program. You can use in HTML file, or you can directly compile and run. How to compile JavaScript program? Already we saw Node compiler. Node what? Index.js. Just like your API you have compiled, you can directly do that. This you can do if the index.js is not having any DOM methods. DOM method means alert, window, open, prompt. If you have document, right, How you will see in console? You cannot see that. For that, you have to link it with the HTML, and through HTML, you have to see it. If it is directly command line only is there, then you can use this. If there are DOM manipulations, you have to link to HTML and use it. That process I will show you. Now, what we have to learn? The language of TypeScript. That means now we have to learn the TypeScript language. TypeScript language basics we have to see. Means how it is different from JavaScript. Variables, data types, operators, statements, functions, OOP concepts, all these, how they are different. That means I am not repeating the content of JavaScript. What is difference I will explain. What is a variable? I don't need to explain. What is data type? No need to explain. Just you need to know the difference. In TypeScript, how you define. Those we will see. That we'll see in next session. Tomorrow we'll do that. So tomorrow we will start working with the TypeScript language. It will take few days time. So to learn all TypeScript, because it is completely different at certain stages, like OOP concepts, like data type handling, little different. Then once you know that, then you can use this language anywhere, not only React. In future, if you are using Angular like technologies, there also this knowledge is enough. That means there also you can use the same knowledge of TypeScript in Angular like technology also, right? So that we will discuss detailing. Tomorrow we'll see.